Lesson 1, Energy. When we say energy, it means is the ability or capacity to do work. An object has energy if it is capable of exerting force on another object to do work on it. Just like this boy is exerting force on this bike in order that this bike will move. Energy also is expressed in joules or ergs just like work. And energy is a scalar quantity. It means it will only be expressed by magnitude and we will not include the direction. Everything that we do makes use of at least one form of energy. Heat energy is used to cook food. This one is yummy. Electrical energy powers appliances, electronic gadgets, and machineries. So I'm sure that you do have a lot of appliances in your home that are using electricity. And then we have chemical energy derived from the food we eat enable us to do our daily work or our daily routine, just like answering the modules. Before we go further, let's know first the fundamental law of physics that govern this universe. We have this law of conservation of energy. The law of conservation of energy states that energy cannot be created, nor energy cannot be destroyed. It can only be converted from one form to another, just like this example. So we have here solar energy coming from the sun, and then it can converted into electrical energy. I think it will be first into chemical energy, then electrical energy, and then this electrical energy turns into mechanical energy in order to make this fan propels. Okay, so basically, you cannot create the energy out of nothing, or you cannot make the energy vanish and turn into nothing. Because according to the law of conservation of energy, energy cannot be created nor destroyed. It will be only transferred from one form of energy into another form. As what we have discussed from the previous slides, energy comes in different forms. It may be chemical, electrical, nuclear, sound, light, and mechanical, among others. In this lesson, we shall focus on mechanical energy. Mechanical energy is the sum of the potential energy and the kinetic energy possessed by a body or an object. And you might be asking, what is potential energy and what is kinetic energy? An object possesses stored energy when it's lifted to a certain height above the ground, just like this bicycle here. It has a lot of potential energy, specifically the gravitational potential energy due to its position. Okay, remember, there are two types of potential energy. We have the gravitational potential energy and the elastic potential energy. In this lesson, we'll focus more in the gravitational potential energy. There's an apple. Mhm. Yep. Me too. I love apple. And then here, potential energy is expressed by this formula. We have the mass, okay, the symbol is m, gravitational acceleration, g, height, which is h, and it has also different units. For mass, we have kilogram. For gravitational acceleration, we have meter per second squared. And for height, we have meter. Okay, let's proceed. Oopsie. So here he is about to climb. Go, 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 and damn. At the top of the tree, his potential energy is expressed by mgh, okay, which mass, gravitational acceleration, and the height is 2.0 meters. It's not 20, it's 2.0 meters. Okay, so let me summarize this one for you. As what I always said, in solving physics problem, you must have first a simple illustration. So I've got it from the video. We have here the mass of the boy, which is 30 kilogram. And then we have the height, which is 2.0 meters. And then the gravitational acceleration, which is 9.8 meter per second squared. We've already agreed this one, that this will be the value of our gravitational acceleration. We will follow the book. So what's being asked? Okay, what is the potential energy of this boy when he's in this location? Okay, so the formula, we have mass times gravitational acceleration and then height. So you just simply do this. So we have here for the mass, we have here for the gravitational acceleration, and for the height. Everything is well and good, so we can solve this problem. So we have this answer. We have 588 kilogram meter squared per second squared, or you just combine this unit and turn into joules. Okay. We are done with potential energy. Now let's proceed to kinetic energy. Kinetic energy, it is an energy due to motion. So if the object is moving, okay, it will have an energy, and that energy is kinetic energy. So if you're running, if you're walking, if you're crawling, or if an object, let's say for example a ball is rolling, it possesses a kinetic energy. So how do you calculate kinetic energy? So you must use this formula here. So we have this kinetic energy is mathematically expressed by this formula. We have 1/2 mv squared, where m or the mass, v is the velocity. And we have for the mass, its units is kilogram, okay? And then for velocity, it is a meter per second, okay? Here is the problem for kinetic energy. We have here Bentong with a mass of 30 kilogram runs 3 meters per second going to his house in order to drink water. Because it's so hot. Just like during the quarantine period. It's so hot. Why is it so hot here in the Philippines? Anyway, the main question is, what is his kinetic energy? So we have here the given, which is the mass, 30 kilogram, and then the velocity, which is 3 meter per second. What's being asked? What is his kinetic energy? So that's kinetic energy. Then we have this formula here, okay? 1/2 mv squared, and then simply just do the substitution. So here, you just simply substitute the value of the mass and the value of the velocity. Don't forget the squared. So how to calculate this one? Get your calculator. Oopsie. You just simply type 1/2. You may type 0.5. 0.5 and 1/2. They're just the same. Hopefully you know that. And then times 30, then times 3, then don't forget it's being squared, so you press this one squared, and then you press equal sign, and you get this answer, 135. Do you have the same answer? Hopefully yes. So we have it here, 135 kilogram for this one, then m squared because m, then it's being squared, and then s squared because s is being squared, just like that. And when you combine this unit, you get this unit, which is joules. So hopefully that is clear. Next topic, that would be the law of conservation of mechanical energy. It is just an extension of law of conservation of energy. In an ideal case where friction and other waste forces are not present, just like for example air resistance, the mechanical energy of an object is also conserved. Again, by the word conserve, it means it won't change. Okay, you cannot create or destroy that. Okay, this statement is called the conservation of mechanical energy. It states that a transformation of potential energy to kinetic energy or vice versa, okay, may take place, but the total amount of mechanical energy will remain the same. To understand further what is the law of conservation of mechanical energy is all about, let's watch Bentong as he demonstrates. Bentong, take your lead. Thank you. hmm When he holds the tire on one side, it has a certain amount of potential energy because he brings this tire into a certain position or distance. Okay, so here the potential energy is converted into kinetic energy, and it's back and forth, back and forth. So notice here in this side of the uh, tire, this one here in this side, let me draw. Okay, here in this position, the tire is in its maximum height. Okay, and it's also at rest. Okay, it's not moving, it stops in the maximum height. Here it is. Look at the potential energy of the object, and this is the kinetic energy of the object, and this is the object. Okay, and it will fall into a certain height, this height, this one. Okay, so notice what happens to the potential energy and the kinetic energy of the object once it falls down. And observe also in this part what happens to the total energy or the mechanical energy. When we say mechanical energy, that the summation of the potential energy and the kinetic energy of the object. So let's observe. So look. So remember, total energy will stay the same. Only the potential and energy and kinetic energy will change. Okay. Hmm. So notice that the maximum kinetic energy is possessed just before this object hits the ground. Okay? And the maximum potential energy of the object is being reached once the object is at the topmost part, okay, of the location, okay, being presented. In this case here. Okay. And then notice also that the potential energy as the object goes down and it moves fast, okay, the potential energy becomes low. And as a return, the kinetic energy increases. Okay, but in this overall situation, the total energy is just the same. If it's 100, all throughout the situation, the total energy is still 100. I hope that is clear. To better understand the concept, let's have this problem solving. Strength in numbers. A 600 grams basketball is thrown vertically upward with a speed of 5.0 meter per second. The question is, what is its potential energy at its maximum height? Again, what's the first step in solving physics problem? You got it right. That's to make illustration. So we have here the ball. Okay, it's thrown vertically upward, okay, with a speed of 5.0 meter per second. That's the initial speed. Okay, So the question is, what is its potential energy at this point, the maximum height? So what are the given? We have the mass, which is 600 grams. But again, you are going to convert this one into kilogram. And I've told you already on how to convert this one, maybe in manual computation or in your calculator. Okay, you just simply divide it by 1000 because we all know that 1 kilogram is equals to 1K. 1K, so 1000. And then just what's the remaining letter? G. So you just put it here, G. So 1000 gram. So use that one as your conversion factor. Then we have the velocity, the initial velocity, which is 5.0 meter per second. And then the gravitational acceleration, your friend in times of need, that's 9.8 meter per second squared. So what's being asked? That's the potential energy at the top. So the formula, we have this formula for potential energy. We have mgh. Do we have mass? Yes. Do we have gravitational acceleration? Yes. But do we have height? Oh, unfortunately, we don't have height. So you can solve this kind of problem if you're going to solve for height. You can use the kinematic equation, but that would be a very long solution. So what would be the shorter one? We have to use our knowledge about the law of conservation of mechanical energy. Okay? Remember that the total mechanical energy is equals to the summation of the potential energy and the kinetic energy. Okay? The total mechanical energy won't change, only the PE and KE will change. So, here, the PE at the maximum height is at max. Okay? And the kinetic energy, okay, is 0 here. But at the lowest part, okay, of when you throw the ball, just right you before it before the ball leaves your hand. Okay, the potential energy is 0. Okay, I hope you still remember the diagram uh, way back before we uh, before we came here. My goodness. And then the kinetic energy in this point is maximum. So do you notice this same pattern? Okay, we have here. So we could assume, okay, okay, that when in this part here, the total energy is the same. In this part here, the total energy is the same. Okay, yeah? So you could assume that the potential energy max, okay, is equals to the kinetic energy right before the ball after the ball leaves the heart of the thrower. So PE max is equals to KE at the start. So what do I mean by that? Okay, let me use another color. The PE, the value of the PE here is also the same value of the KE here. So that's why we made this statement. Mm-hmm. So, so we can solve for the kinetic energy, and we know the formula of kinetic energy. We have 1/2 mv squared. Okay. Do we have mass in the given? Yes, we have mass in the given. Do we have velocity? Yes, we have the velocity in the given. So we have all the values in the variable, so we can solve this problem. Mhm. So just simple substitution. We have here 0.6 kilogram times 5.0 meter per second squared. So you can use a calculator for this one. You type 0.5, we convert 1/2 into decimal form, times 0.6 times 5, then squared. You get this number, 7.5 or 7.50, because we will use two decimal place to be consistent in our answer. So, you, the unit would be kilogram, then m squared over s squared. Or you just simply merge this one into this unit, joules. And you have this answer, okay, for kinetic energy. But we're not done yet. Okay, we're not done yet. Okay, here. Since we already established that potential energy at maximum has the same value in this position with the kinetic energy, okay, at the start. So Ke is equal to 750 joules at the start. So we could assume that the potential energy is 7.50 joules at the top. So I hope that is clear. Second problem with the same situation. What is its mechanical energy at height of 3 meters? So given we have the same 0.6 kilogram, then the velocity is 5.0 meter per second, and the gravitational acceleration is 9.8 meter per second squared. But there's an additional given, and that is 3 meters. So you include this one here. So what's being asked? We have the mechanical energy. So what's the formula for mechanical energy, or the total energy? We have the potential energy plus kinetic energy. But you have to break this down. So here, if you're gonna smash this one, it turns into mass times gravitational acceleration times height. And when you break down this one, it turns into this formula. Then just pure substitution. So we have here for the mass, we have here for the gravitational acceleration, and for the height. We have also here for the mass, and then the what's this velocity. So get your calculator and do this 0.6 times 9.8 times 3. You have 17.64 joules plus 0.5. I think we're done solving this in times 0.6 times 5 square, and that's 7.5. Yeah. So you add this two and you get this answer. This will be the mechanical energy. So I hope it's clear. Let's go to next sample problem. A roller coaster starts from rest at the top of a 20-meter hill. The mass of the roller coaster together with its passengers is 1,250 kilograms. Find the total mechanical energy of the roller coaster and its passenger. So again, the first step is to have some sort of illustration. So this one, from this point up to here, this is 20 meters. Forgive my handwriting. Okay? Is it handwriting? Mouse writing? I don't know. Anyway, so since the roller coaster starts from rest, its mechanical energy is purely gravitational potential energy, and the kinetic energy is 0. So in this point here, in this very point, the PE here is maximum, max na max. And then the kinetic energy here is the minimum, or 0. Okay, you have to remember that one. Next, so given we have the mass of the roller coaster, which is 1,250 kilograms. We don't need to convert this one because it's already kilogram. the height is 20 meters, and the gravitational acceleration is 9.8 meter per second squared. All is well. And what's being asked? By the way, we have to include the kinetic energy to zero at this point. What's being asked? The mechanical energy. And we all know that the mechanical energy is the summation of potential energy plus kinetic energy. Okay, do the substitution. So you break this down up. We know that the formula for potential energy is mgh. So we have the mass, we have the mass, we have the gravitational acceleration, and we have the height, plus the key E, which is 0 because of the given situation. So I hope this statement here is clear. Now, so you do simple substitution and you get this number. Okay, let me check using my calculator. 1 to 50 times 9.8 times 20, and that's 245,000 joules. Okay, that's that mechanical energy, the total energy. Here is the second part of the problem. What is the speed of the roller coaster with its passengers at the top of another hill that is 15.0 meters? So in the first situation, we have it here at 20 meters, and then it goes down, it gains speed, and then it went here at this point. So the question is, what is the speed of the roller coaster at this point? So given mass is equals to 1,250 kilogram. Okay, height is 15 meters. We get it from here. And then the gravitational acceleration. Okay, well and good. This is just more like the same with the problem number 1. And then we have here the mechanical energy from the previous problem. Okay, so that's 245,000 joules. Okay, what's being asked? That's the velocity. And between the potential energy and kinetic energy, which of the two has a variable called velocity or speed? Okay, we obviously that's the kinetic energy because this is the formula of the kinetic energy, 1/2 mv squared. Then you just simply simplify this formula in order to get the formula for velocity. So get rid of this 1/2 by multiplying 2 to the kinetic energy, and you get this 2k is equals to mv squared. Next would be get rid of this mass. Okay, you divide both sides by m, and you get this. Okay, and then erase, and then after this, okay, you get v squared is equals to 2ke over m, and then you square root the 2, okay, both sides, and you get the simplified formula for velocity. But the question is, okay, do we have value for these variables? How about for kinetic energy? Oh, we don't have a value for kinetic energy. How about for mass? Yes. So we can't use this formula yet, okay, because we still lack the value of the kinetic energy. So let's find the value of the kinetic energy. There's the formula. We have the mechanical energy is equals to potential energy plus kinetic energy. Here's a solution. Okay, pure substitution. We have here for mechanical energy. For PE, hopefully you already master this one. We have the mass, gravitational acceleration, and the height. So plug it in plus key. This is what we're looking for. So get your calculator and then plug it in. 1 to 50 multiplied by 9.8 times 15, and you get this number. Okay, 183,750, and that's joules. Okay, and then, okay, you have it here. So simplify. You may transfer the kinetic energy here, and then transfer the value here, or you may do this. It doesn't matter. Okay, and then Yep. So once transferred here in this other side becomes negative, then simplify this and you get this number, 61,250 joules. Okay, are we done? No, we're not yet done. Okay, so here, hmm. So we have here, let's go back to the formula of the uh, velocity, which is square root of 2 k over m. Okay, and then, okay, just pure substitution. Okay, so we have now the value of k, which is this one, 61,250 joules. And the value of mass is 1,250 kilogram. And then simplify. So let's see if I'm correct. We'll use the calculator. Here we have 2 times 6,1,250. Okay. Divided by 1,250. And then you square the 1 and you get this number. Let's see if I'm correct. Okay. And if you're gonna break this down up, you'll get the formula, which is, I mean, not the formula, the unit, which is meter per second. Then we already, um, what's this? You will already agree that we have to round off our answer into two decimal place, and then you have this. Okay. So digest, inhale, exhale, and then if you have some questions with regards to this topic, please feel free to contact your physics teachers. They are willing to answer all your queries and questions. So I think I'm done. Thank you and have a good energy.